I just want to say and thank Francesco for coming. So this is something of a special keynote. We wanted to get his perspective on success in open source projects. Maybe we can learn something. So again, please take a little bit extra time. We can have a little discussion before we go.
Thank you. Thank you very much. First of all, thanks a lot for inviting me. Thanks to Piero, and it's a pleasure to be here. I'm here to tell the story of a project that I've been involved for quite some time now. This is the outline. Yeah. Do I get also a pointer? Yeah, never mind. Yeah, so we're briefly going through what is Modelica, what is OpenModelica, the story of the open source Modelica consortium, and some consortium member stories, which I believe are interesting, and finally some take-home messages for your community. So first of all, what is Modelica? I guess not many of you are familiar with it. Who is besides these two gentlemen? Oh, okay, good. Then I'll briefly say something for those of you who are not familiar with the whole thing. Well, Modelica is a community or an ecosystem, I would say. First and foremost, it started as a modeling language, which is fairly odd from a certain point of view in the field of programming languages. It all started at the end of the previous century, more than 25 years ago. It's an equation-based declarative modeling language, which basically means you describe basic components by writing differential algebraic equations, regardless of how they have to be solved, which is a very nice feature because everything that can be described in terms of DAEs can be modeled. So it's 0D and 1D models in whatever domain, electrical, chemical, thermal, fluid, whatever. So you get multi-domain or multi-physics out of the box. And then you can use connectors and use them to define hierarchical modular system models, which is very useful for engineering applications. And last but not least, you get object-oriented features like inheritance, encapsulation. This is very nice for handling complicated projects and models. One very important thing of Modelica is that it's an open standard. It's not strictly speaking a standard because it's not an ISO or IEEE standard, but it's kind of standard. And it's tool independent, which means you can encode your modeling knowledge in something which doesn't lock you in with a specific commercial tool. And it's supported by multiple commercial and open source tools. With Modelica, you can do a lot of different things, multi-body mechanical systems, fuel cells, power plants, cars, electrical circuits, whatever. So it's very broad in terms of application. Everything that can be described by DAs, basically. It's also important to spend a few words about this ecosystem. So the language is promoted by the Modelica Association, which is a non-profit entity. It's a very interesting story because it's an association that takes in tool developers competing against each other, industrial users, and researchers or academics. And of course, we fight all the time, but eventually the thing has been carried along quite well. And they used to say that the language should be designed by one person, not by a committee. Yeah, maybe it's a bit bloated, but I think the committee did a good job here, based on my experience. So the Modelica Association started promoting the Modelica language, but then it developed other standards. So after the language, and associated libraries, specifically the Modelica standard library, which contains a lot of useful stuff and it's available with a very liberal license. But then other things came that you may know. FMI has been a very popular result. FMI is a standard for exporting models for simulation across tools. It's supported by more than 150 tools currently. And then now we have EFMI, which is a variant of FMI for embedded applications, very interesting for automotive, and other standards that build on top of FMI. So these things are going. And in fact, FMI is currently, I would say, more popular than Modelica itself. It has found a very widespread usage. So that's a very short introduction to the Modelica ecosystem. So in this context, what is OpenModelica? I first wrote OpenModelica is an open source Modelica tool. In fact, it's the open source Modelica tool. There used to be another one, which was JModelica, and it went closed source in 2019. So currently, it's the only choice of open source tool if you want to use Modelica. It's basically two pieces. There's a command line Modelica compiler that can also run in the background as a DLL, basically. And then you have a graphical user interface that you can use to build models, run simulations, and check the results. There are many other parts of the tool, but since our time is limited, I'm not getting too much into the details. You can ask questions if you want. What is the story of OpenModelica? Let me go quickly through a timeline. I think it started as a master's thesis or possibly a PhD thesis. Adrian Popp was the first one who worked on that. He's still the technical coordinator of the whole project. And I would say for the first few years, it was really a computer science playground. A compiler, a weird compiler using a weird programming language. It's actually a modeling language which is declarative, little bit like the old Lisp or what was the other thing? Stuff from the 70s. So it was nice to play around for computer scientists, but you couldn't really do anything useful back then. I tried to play around with it around, when I visited Piero in 2006, it was really, really bad. Gerhard Schmitz had one of his PhD students, he gave her a task to do something like a heat exchanger model using OpenModelica, and that was really bad. But it kept growing, and in 2008, Peter Fritzen, who started the whole thing, had a nice idea to establish a consortium, in this case, not a foundation, to try to move this thing towards also, let's say, industrial application. For a few years, there was limited usability for some selected applications. There were lots of limitations. Only parts of the language were supported. The numerical solvers were not that strong, and so on and so forth. But you could start doing something interesting. And then I would say from 2014 to 2020, in some areas, you could really start using serious work. We used this software for several applications. We'll cover a few of them later on. And I would say in the last few years, we finally got wide applicability in many areas. We're probably still not, we are definitely still not at the same level of the leading commercial alternative, which is currently Daimola, but we can fight the fight. I will talk about that later. The source code has been on GitHub since almost at the beginning. You can have a look at it. It's a bit weird. The compiler is written in an extension of Modelica, which is called the MetaModelica, and I think there's less than 50 people in the world that can program this language, but never mind. New students cast this up very quickly when they have. Maybe we will switch to C++ in the future, we'll see. Or Julia or whatever. Continuous testing and integration framework was activated in 2016. This was a major milestone in achieving more reliable operation. And this particularly means that each and every commit has to pass like 3,000 tests. And even if one fails, you can't merge in unless either you solve the problem or you have a good motivation to change the reference files. It's a bit painful, but it's really, you can't do without it. It's a multi-OS thing. We compile for Windows, for a number of Linux variants, Mac OS, kind of, which is kind of painful because this thing can fail in an exponentially growing number of cases. But yeah, some people will never use Windows and some people will never use Linux. So we have to do it, and it works quite well. I would say that the Linux version is more efficient because it started as a Linux thing, and then we have backports using UCRT64 and then MinGW, these kind of things. I think you're familiar with this problem. This is, I mean, as the director of the consortium, this is, I mean, I'm not losing sleep at night, but this is really the problem. On one hand, you want a lot of research and innovation, and you have PhD students doing fancy projects, and most importantly, you get research funding. And the problem, however, is twofold. First of all, research funding is always obtained because you are making fancy statements. You want to reach the moon, Mars, and beyond. And then maybe you reach low Earth orbit, kind of. And then the budget is over, and most likely the code will end up on a dead track. That has happened multiple times in my life. That's the first problem. The second problem, which is related to the first, is that if you have PhD students developing software, their goal is to get a PhD and publish something. It's not to provide computer code that will last for 20 years. It's a completely orthogonal thing. But you need research, and you need innovation, you need PhD students, and you need research funding. On the other hand, you need the boring stuff like maintenance, stability, quality control, and so it's a delicate balancing act. You need these two things, and you need to find some kind of compromise. Now, I'm not really sure how you are actually trying to solve this issue in your community, but I guess it's probably, and I'm not, I mean, at the beginning, we were like 90% here. Yeah, well, 99% here and basically zero. Now I guess it's something between 50-50 and 60-40, which is probably the right balance. I'm not sure. SU2, how would you qualify it? Like 50-50? Not really. No. That's the dream. Okay. So this is the big question: who pays? I tried to make it. Yeah, maybe I could have made it even bigger. This is a big deal. So I'm going to spend a couple of minutes to explain you how we are dealing with that. So this consortium was established in 2008. Currently, we have about 30 company members. It's both large companies, but also small and medium enterprises, some very small ones actually, plus some research institutes. And about 30 academic members is basically universities, which means small groups inside. Membership fees depend on the size and whether you are profit or non-profit. You go from 600 euros per year to 24. Of course, I mean, Siemens or EDF pays a lot more than TUDEV or Politecnico. The thing was started by Peter in this way. Initially, I was a little bit skeptical, but I have to say that eventually it worked. The code base is owned by the consortium. This is absolute, ownership is a very big deal. And it's very important that the code is owned by a non-profit entity. Otherwise, it's a disaster. In fact, the other open source Modelica compiler, which was JModelica, used to be GPL, but it was owned by Modelon AB, which is a for-profit company. And eventually they switched to closed source because they understood that they were not getting anything from the community. And of course they didn't, because why should I give my time and effort to provide code to a company that has ownership and can at any point in time switch to closed source? You would never do that. And that's actually what happened. So eventually they said, okay, never mind open source, we go closed source. So the ownership is of this non-profit entity with a backup. If the entity somehow fails, the ownership goes to Linköping University, which is still a reasonable deal. And then it's released under two licenses. One is Affero GPL. It's basically GPL with all the copyleft stuff. But if you're a member of the consortium, you can also get it with a closed source license, which is known as OSMCPL. So basically, you can add some parts, some private parts to the code without being obliged to release them. You can do that if you pay a fee to the consortium, and you can keep on doing that until you pay the fee. That is basically the Faustian bargain. it worked quite well. So, I mean, we got to some interesting numbers. Now, what are the membership benefits? Let's say from a legal point of view, the main benefit is that you can use the source code in commercial products. And some members use that. And in some cases, this is the only reason that you can actually use with upper management to really justify paying the fee because you have to. But there's other benefits like you get a little bit more priority in getting trouble fixed. I mean, at least we know who you are. Of course, I thought that this would be enough, but it turns out in real life, it doesn't really work. But some companies understand this. They have an interest at OpenModelica filing in the long term. And of course, you need some money and resources to do that. And last but not least, if you're a member of the consortium, you can participate to the governing bodies, the assembly and the board, and eventually determine the long-term future of the whole thing. Now, where do we get our money? It's basically two main lines. One is actual monetary contributions, and this is, I can't stress it more. This is absolutely work, which is putting, and you need to pay for it. There's no escape. So we get market fees. We get we call that DFD, that is funding development contracts for chip development. So if you need some feature is not there and it's not happening, you can sign a contract with a consortium at the time the certain deadline with reasonable certainty. And these two things combined allow us to pay about 5 full-time equivalent. It's actually full-time employees plus a number of people who are working like 30 to 70% of their time for the consortium. And when we, now 5 is really good, but when we reached, I would say 2, it really started to make a difference in terms of going from playground to serious thing. It really showed. So this is really essential for quality and maintenance. And then we have in-kind contributions. We have consortium members that are getting research funding from the European Commission or from national funding agencies. And they typically have PhDs paid by these fundings, and they contribute to the source code. This is absolutely essential for innovation. We have contribution to the source code by some industrial members, direct one. I will mention one in a minute. And also sometimes there's people that we don't know, we only know their nickname on GitHub, and they make some contributions. For example, the 3D animation feature was recently very much improved by, I mean, they're not anonymous, but we only met them online. And it's been slowly but constantly growing since 2008. The derivatives are still positive. Now, I don't want to get too long because lunch is kind of looming. I will just quickly go through 5 short member stories, which I believe are interesting to give you a flavor of what happens. The first story is ABB, one of the founding members of the consortium. Here, ABB, this is most notably my colleague Rüdiger Franke, who made his PhD on using, let's say, Modelica for optimal control, MPC. And then made it into a commercial product eventually, or ABB Optimax. So this optimal control needs some kind of process model, and this is actually generated using FMI, using OpenModelica. In fact, before 2015, it was generated with a commercial tool, which entailed a number of licensing issues, and so ABB was really eager to get, let's say, unchained, and the policy of OpenModelica from the point of view of generated code is very liberal. Generated code, you can do whatever you want with it. We don't have any claim on it. Not only that, but the regular runtime of OpenModelica uses garbage collection, which is very comfortable if you write code, but it's not really good for real-time industrial use, because every now and then the thing freezes because it has to tidy up the memory. So actually, Rüdiger and some of his colleagues actually contributed a separate C++ runtime with static memory allocation precisely for this application. And they keep it well maintained because it's eventually getting into one of their industrial products. So you understand ABB has a long-term interest in the well-being of the consortium. In fact, in the beginning, this is off the record, there are, of course, many business units in ABB, and there was one business unit, I think it was Turbo Machinery or something, that was that was actually paying the fee. And then at some point they said, we don't care anymore, and they wanted to cut the membership. So Rudiger sprang up and said, okay, my business unit is gonna fail, and it's been very careful with that. Second interesting story is EDF, the French power company. EDF has pioneered the use of Modelica for modular power plants since the very beginning. They've been very active. Daniel Bousquelin started this venture many years ago. He's unfortunately passed away a couple of years ago. They started using Daimola, but then they increasingly see OpenModelica as a good alternative, so they are contributing. But not only as an alternative to commercial tool, but they are also interested at proposing extensions of the language. A few years ago, they were working on data reconciliation, so using the model to let's say, clean up the data and improve the quality of noisy measurements. And more recently on an interesting topic, which is requirement specification and verification. So they are developing formal languages to specify requirements. And then you can just compile them and make sure by running simulations that all your requirements are actually fulfilled. So doing these things with a commercial tool vendor would be a big deal, because if it's not in their plans, they're simply not going to do that. Here, it's much easier. And they funded the implementation of such extensions, and maybe at some point they will become part of the standards. We will see. So again, you see long-term interest in the well-being of the consortium. Third story, Bosch Rexroth, leading company in industrial automation. As I understand, I'm not one of the customers, but as I understand, they have an in-house tool that can be used to build basically system models to help with sizing and the commercial side of it. So they tightly integrated the source code of OpenModelica into their tool. And for that, they needed this provision of the dual licensing. For them, it being fundamental. And also, since they actually use this with their customers, of course, they initially had a lot of issues because of the quality of the graphical user interface was not up to the task. So they funded a lot of specific improvements. And what is good is that they paid for these improvements that were important to them, but then the whole community, of course, benefits. So the quality has improved for everybody, not just for them. So again, they are faithful and committed partners of the consortium for the long run. I'll definitely mention, I have 5 stories, so it's just 2 more. I will just definitely mention RTL. This is the French transmission system operator. This is a very nice story because thanks to the vision of a few, actually it was 2 people, Adrien Gironnet and his predecessor, whose name now I cannot remember, but it will come back. Basically, in this world, the world of national transmission system operators in Europe, they are federated into an association which is
for the public electric grid.
It's a high voltage electric grid. So there's a body called the NSOE, which collects all the 30-something transmission system operators that make the European grid. Most of them use commercial tools, except historically 2. One is the Italian TSO, Terna, and the other one is the French RT, which traditionally had in-house codes from the 70s that eventually they had to retire because they could not keep up with their maintenance. And RT, and the problem here is that the European network is getting more and more integrated, particularly with renewables. And unfortunately, so if they exchange data, they also need to exchange models. For dynamic models, data is not enough. And unfortunately, different commercial tools give very different results starting from the same data. That's a big deal. So RTE is trying to promote a vision whereby, and by the way, they give different results and you have no clue why. Because the models are closed source, the solvers are closed source, and you get 6 different results with 6 tools, and who is the winner? You don't know. So they've been promoted open source primarily because this allows for inspection and criticism and double verification. It's a very long-term program, but it's going on. So they chose the open standard Modelica language for system modeling. I would say around 2013 they started to do this. They started using OpenModelica and have been actively supporting the consortium since 2015. I met them at the Modelica conference in Versailles in 2015, and since then we've been working together. What is interesting, they have developed a comprehensive open source simulation system. It's called Dinavo for the French transition system, but it's open source. You find it on GitHub. And it uses Modelica to describe component models and uses OpenModelica as a simulation engine. And I'm very proud of the fact that they are currently using it online for voltage management. So the voltage management on the French grid is using OpenModelica generated code. And according to Rüdiger's claims, some 7% of power generation in Germany is running controls based on OpenModelica code. It's mostly critical. It's mostly coal-fired power plants. So I hope that this fraction will be reduced in the future. But they are moving into wind turbines and all these kind of things. So I'm happy that they will still use that in the long term. So we are actually having an impact on the real world, and that once more long-term interest. And last but not least, let me spend a couple of words on Dynamica, which is a small engineering consultancy that I founded with some colleagues some years ago. It remains small, but we're having lots of fun. We did several things with OpenModelica. We helped RTE doing their modeling because they had very good ideas, but they were a bit naive in the way they used Modelica, so we had them using it in a little bit more professional way. We have developed a complete modeling turnkey solutions in very diverse fields, power plants, hydraulic automation, industrial cooling systems, refrigeration containers, modeling of medicine intake, you name it. And all of this with OpenModelica. And what is interesting here is that OpenModelica often lowers the entry barrier for customers which do not really want to pay commercial licenses. This is particularly critical for the Italian market, where you have lots of small and medium enterprises. And for them, this can be really a game changer. By the way, in most cases, you can start with the open source tool, and then you always have the option to move to a commercial tool thanks to the standards. So this is some kind of safety insurance, but you can start with open. Yeah, so you get the story. There are more stories, but I think this gave you some ideas. So to summarize, I think there are some possible take-home messages for your community from what I understood from Pierre. Number one, open source software works well. Well, you already know it, and I mean Linux demonstrated that much better than we could, but I mean it works. There's no question about it. I think this is very important. Make sure that you have a few committed industrial partners with strategic long-term interest in the software. That makes all the difference. Otherwise, you're always walking on a tightrope, and when the wind blows, bad things could happen. I think from this point of view, we're quite safe. You can't rest on your laurels, but it helps. As I already mentioned, make sure that you have enough budget for boring work, maintenance, quality, even just keeping up with Linux versions progressing and compatibilities within libraries and then Docker and whatever. I mean, it's a lot of boring work. But yeah, some people have fun doing this, but you need someone that does it even when it's not fun. PC students are essential, but they're not enough. That's the other side of the coin. Continuous testing and integration is absolutely essential. I'm not sure if you're actually doing that. Are you? Right. Okay. This made this made a really big difference when we introduced that, and there's not going back. And last but not least, let me spend the last word. I think you already know this, but what is interesting is community-based open source development. What I mean is, I'm not really an expert in strategies or how do you call that, company management, but this message here, I think, is quite clear. The main interest of the consortium is not to sell simulation software for a living. If you sell the simulation software, then you have certain objectives. You have to continuously introduce new features because otherwise there's no revenues. That is your main strategic objective. In this case, that is, you don't care about that. The consortium members have a shared common interest at having some good software to support their internal processes, even if they are competing with each other. So you're not focusing on making money with the software. You're focusing on making a software do what is good for you. And I think that if you can manage that really makes it. And with this final message, I thank you for your attention. And I took 10 minutes more. I hope it was.
Yes, there are probably plenty of questions. Maybe there are some questions that we can ask right now, and there is, of course, plenty of time in one.
Absolutely.
Practical questions?
Maybe just the curiosity. Why at the beginning you didn't decide to create a consortium and not a foundation, knowing that I'm ignorant in this kind of.
Maybe I'm totally. The OSMC is incorporating in Sweden, and when Peter started that, he was. Now I am director, but back then I was nobody. I was just a let's say, enthusiastic member. So I think maybe it was simply because it was easier from a legal point of view. Also. But I think
You don't pay taxes.
It's a non-profit.
Not for profit.
It's a not-for-profit.
Probably a consortium.
I think they're pretty. And the idea of the consortium is fine because you have these very diverse entities which are coming together because they have some common interests. That works quite well. I think, the foundation stresses more that you have this body that can carry on a legacy or something. Here it's more like you have an active community. but I think at the end of the day, it's more or less the same.
No.
Yeah,
Please.
Probably say that first started drawing the line to SU2 because you mentioned this dual licensing model,
Yep.
the AGPL. I think SU2 is in the state with the LGPL.
Mm-hmm.
And without this contributor license kind of thing that we didn't do, that currently this right it's not able for the SU2 Foundation to capture the code in such a way that we are able to distribute SU2 under different licenses. So that I think that's completely great for us.
It's blocked, yeah. That must be going when we collect from every single person who's ever contributed a license.
Yeah, I didn't mention that. The CLA is absolutely fundamental. Before you can make a commit to the code, you sign an agreement that you are passing all the copyrights to the consortium. Otherwise, it's hopeless. Maybe we didn't do that at the beginning, but nobody is going.
Oh, yeah, that's my question. So we went to date, we have never done this. So that's part of the problem. We would have to go.
That's a big deal. That's a big.
So we're stuck a little bit. We have a license without having all the agreements. We can't even change that license, even if we just want to switch to another LGPL. We can't.
But I think maybe the more you wait, the more difficult it will become. So maybe you could have a task force that at least attempts to do that.
You're not going to have more talking. Sorry.
Yes, my question would be, because now the OpenModelica has this power, let's say, to distribute in other licenses. And my question is, and I think you mentioned that, what happens if the consortium kind of dissolves? You mentioned like the right then goes to your.
There's a fallback clause in the bylaws that in case the consortium is disbanded for any reason, the ownership of the software is passed on to Linköping University. I'm not sure if universities qualify as non-profit in Sweden. I guess so. I mean, it's a kind of a nuclear option. And by the way, since we basically do not have any financial reserves, so now we have an arrangement whereby some of our employees are not actually employees of the consortium. They're employees of a company which is owned by the consortium. So just in case this company may fail, but the consortium can still keep the copyright, just in case.
Josh?
In terms of attracting new insurance users away from commercial software, but when you say are there any challenges that you would have faced or trying to convince someone, an engineer, however on to move away from something that they already knew? Would you say that there's any shared characteristics between companies that are willing to do that and companies that aren't?
Good question. Here, the elephant in the room is Networks Incorporated. I mean, and I always, I mean, it's not a joke. It's real. I joined the IEEE in 1991 as a student member, and the Control System magazine had an advertisement for MATLAB in the back cover, and it's consistently been like that for like 35 years. So the main issue that we have here is not really OpenModelica, it's just Modelica. I mean, that there are commercial solutions which are very well established, and some people are just, for their peace of mind, they just want to keep going with that. On the other hand, we are seeing, I mean, there's been in recent years several companies. This is an interesting trend. It's companies that develop domain-specific tools like Big Silent, the Factory, which is a tool for power system simulations, or COMSOL, 3D multiphysics. These two companies need some kind of middleware. I mean, they do need to put other stuff in their models, which could be control systems or maybe reduced order models of generation units, stuff like that, and they're struggling to do it. So they are thinking maybe we could use Modelica for that, and then they are coming to the consortium in order to basically avoid the pain of developing a Modelica compiler from scratch, which takes at least 10 years based on the experience that I've seen. And they're popping up with increasing frequency. So I think that is one interesting path.
But I can partially maybe answer the question applies to SU2. In the conversations we had with companies in the area of turbomachinery, the interest is to use SU2 and the people around it to test new, very difficult problems. Of course, the main feature of SU2 that is the joint-based optimization is very attractive because it's not widespread and industrialized yet. So some of these companies use their own codes that have been there since the 60s, the 70s. So what also Francesco mentioned, at some point it becomes hugely expensive for them maintaining these codes.
Or impossible, when people retire.
For more medium companies, I am aware of some small companies for which their high licenses cost is an issue, and they started to use open source software. Of course, then from small companies, you cannot ask huge membership fees, but it is good to have this large range of rather different members, and everything counts then when you need to pay the salary for some software engineers.
So would you say, did you have conversations with these larger companies, the larger companies that are really looking for
kind of like a consultancy service for the specific problems, or they're looking for?
The problem and the difference with OpenModelica is the fact that, as we have seen, they succeeded in having the software embedded in some of their products. At that point,
Yeah, kind of. I mean, they could always switch to a different Modelica tool, and I think this is a very healthy concept that you're not completely hooked. But of course, they do see advantage, and as I said at the end of my presentation, I think sometimes this is overlooked. I mean, if you have commercial software vendors, they have their own legitimate strategic goals, which may or may not be aligned with yours. If you manage to set up a consortium where maybe there are companies which are also partially competing with each other, but they do not have any conflict in this area, I mean, you can actually decide what you want to do rather than just begging, please give me this feature, and they will reply, we will consider that for the next release. It's a completely different attitude. Oof. Well, the people with whom we work are already they've already seen the lights. So, yeah, or you just keep on going. That's
Yes, I so again, direct question. And then in the same line, for example, you give me an example of this. How company given for you
no, the 3D was private individuals. No, it's ABB is actually made a contribution to the runtime.
So, UBs, it's like you need a lot of convincing. It's like have to do like these public contributions.
I mean, from my experience, at the end of the day, it's a few enlightened individuals that make the difference. I mean, there's name.
for example, here when they were working at Bosch,
I mean, I write ABB, but it's Rüdiger Franke who has catalyzed this thing. And when I say RTE, it's Adrien Guironet, who had, I mean, he had this very strong strategic long-term vision. And then, of course, I mean, he's not a one-man band. There is a community. And then now Adrien was promoted to do other things, and others are carrying on the legacy. But I think you really need some individuals with a vision. Otherwise, it's not really going to happen.
Yeah. Another small question. So apart from mentorship fees, does the innovative demonstration also bring consultancies?
In principle, yes, but we are doing something like this a limited amount because there is a very common problem. You develop a Modelica library with a commercial tool, and then you want to run it with OpenModelica, and say typically 70 to 90% of the models work well, and then you have some glitches. And sometimes the glitches are in the OpenModelica tool, which is not up to the task. Sometimes the glitches are in the code, which is not really 100% standard, and maybe the commercial tool accepts it anyway, so you have to adapt. So now we are offering some services to basically do this thing. And what is interesting is that, I mean, the consortium by itself does not have, I mean, the consortium employs software engineers, computer scientists, and applied mathematicians. We unfortunately, we don't have modelers in the workforce. But luckily, we have members of the consortium that can do this job. So eventually, we find a way to accommodate. Currently, it's not that much, but it's something that could grow. I mean, this could become some kind of competence center.
All right. Well, we now have some lunch, so maybe if you have other questions.
I'm staying until this. Thank you very much. Thank you.